Good morning to one and all present here. Today we are going to discuss about data converters in linear integrator circuits. What are the topics we are going to discuss about in this presentation? First, we are going to discuss about what is meant by data converter, what are the types are available in the data converters, and first one is the digital to analog converter, and what are the types as available in the digital to analog converter, and we are going to discuss about weighted register DAC and 3-bit binary weighted register DAC, and we are going to discuss about virtual short concept and nodal equation, and what are the disadvantages in these weighted register DAC. First, what are the types available in the digital to analog converter, what are the types available in the data converters. First, there is two types of data converters. First one is the analog to digital converter, and second one is the digital to analog converter. Now we are going to discuss about digital to analog converter. The digital to analog converter means it converts the digital input signal into an analog output signal. The digital signal, it represents the binary code. It is the combination of bits, zeros and ones. And this is the block diagram of digital to analog converter. First, it consists of number of binary inputs and single output. In general, the number of binary inputs of an digital to analog converter, it will be a power of 2. And we are going to discuss about types of digital to analog converter. There is two types of digital to analog converter. First one is the weighted register DAC, and second one is the R2 or ladder DAC. First one is the weighted register DAC. First, weighted register DAC means it produces an analog output. It is almost equal to the digital input by using the binary weighted register in the inverting adder circuits. In short, the binary weighted register DAC is also called as the weighted digital to analog converter. This is the circuit diagram of 3-bit binary weighted DAC. In this, the bits of binary number can have only one of two values, that is either 0 or 1. We consider the 3-bit binary input. First one is the B2, B1 and B0. The B2 and B0, first one is the B2 denoted as the most significant bit, and B0 represent the least significant bit, and the digital switches are connected to the ground whenever the corresponding inputs are equal to 0. Similarly, the digital switches are connected to the negative reference voltage, that is minus VR, when the corresponding input bits are equal to 1. And the non-inverting input terminal of an operational amplifier is connected to the ground. That means 0 voltage is applied to the non-inverting input terminal of an operational amplifier. And we are going to discuss about virtual short concept. The virtual short concept means the voltage at the inverting input terminal of an operational amplifier is same as that the voltage present at in the non-inverting input terminal. So the voltage at the inverting input terminal node will be 0 voltage. This is the nodal equation of the inverting input terminal. First one is the 0 plus VR B2 divided by 2 naught R plus 0 plus VR B1 divided by 2 power 1 into R plus 0 into VR B0 divided by 2 power 2 into R plus 0 minus V0 divided by RF equal to 0. This is the nodal equation. So we simplify that. So V0 divided by RF equal to, we place it in the left hand side, and right hand side we are moved to plus minus plus. So we are B2 divided by 2 naught R plus VR B1 divided by 2 power 1 into R plus VR B0 divided by 2 power 2 into R. So we calculating the V0 value. So V0 equal to VR RF divided by R into B2 divided by 2 naught plus B1 divided by 2 1 plus B0 divided by 2 power 2. So substituting the equation, R equal to 2 into RF. So we replacing the R value into 2 into RF. So RF is cancelled. So V naught equal to VR divided by 2 into B2 divided by 2 naught plus B1 divided by 2 1 plus B naught divided by 2 power 2. This is the output voltage equation of the 3-bit binary weighted register DAC. In this the number of bits are 3 in the binary input, so we possibly having 7 values of an output voltage by varying the binary input value from 000 to 111 for a fixed reference voltage. The generalized output voltage equation of an n-bit binary weighted register DAC is the this one is the generalized output voltage. So V naught equal to VR divided by 2 into B n minus 1 divided by 2 power 0 plus B n minus 2 divided by 2 power 1 plus up to etc. B naught divided by 2 power n minus 1. And in these binary weighted register having disadvantages, there is an disadvantages in binary weighted DAC. The difference between the resistor value corresponding to the least significant bit and most significant bit increase as the number of bits present in the digital input increases. So it is difficult to design more accurate resistor as the number of bit present in the digital input increases. These are all the disadvantages of binary weighted register. So we overcome this disadvantage. We go with the R2R LiDAR DAC. We are discussed above in discussed R2R LiDAR digital to analog converter in next presentation. Thank you for watching.